This is a worksheet of chapter number 1 in which I have compiled all the questions, paper 1 and paper 2, all of the questions that we have had so far from the year 2023, which represents a physical quantity. The very first option, 3.0. So 3.0 is a number. All the numbers, these are just abstract concepts and these are non-physical quantities. So A can't be the right option. Kilogram is not a physical quantity. It is a unit of a physical quantity. Which quantity? Mass. So it's not a physical quantity. 40%, once again, it's a number. Numbers are non-physical quantities. A physical quantity has two parts, two components, a numeric value and a unit. So C is the right answer for the first one. The first one was kind of an easy one. Let's move on to the next one. Slightly advanced question, not too advanced, slightly advanced, especially for the ones who are just starting off with this syllabus. So here we are given with an equation and we are told that B and C are constant. So these are constants, but they are not unitless constants. They are not constant numbers. These are some constant quantities. So the unit of D is meter square and the unit of capital T is second given in the question. So what do we do in these kind of question? We need to find the units of B and C. We insert the units into the equation. We use the principle of homogeneity of equations and from there we can find the unknown units. So I'm going to insert the unit of T. It would be 1 over S because the unit of T is second. So it would be 1 over S equals B as it is because we need to find the unit of B. We don't have any information so far. Square root of, what is the unit of D? It is meter square. So square root of meter square plus, and we don't have the unit of C either. So B and C, the units of these two have to be found out. So you realize in the very first step you can cross out these two. So you'll be left with a simple form. 1 over S can be written as S minus 1 per second. And then this thing can also be written as B over M plus C. Now check it out. How many terms do you have in this equation? We have 3 terms. First one, second one, and plus 3 being the third one. We have 3 terms in this equation. And the terms can be added only if they have the same unit. Otherwise the terms cannot be added. I mean, think about it. So for example, we cannot have an equation that looks something like this. 5 seconds equals to 3 meters plus 2 kilograms. No, you can never have an equation like this. Why? Because the units, the dimensions, the units are different. So the units have to be the same. Only then the quantities can be added and the final answer would also be in the same unit. So out of these three terms, if we know the unit of any of these terms, we can eventually find the unit of the rest of the terms, because whatever the unit of the first thing is, that would be this, whatever the unit of one of the term is, for all the remaining terms the unit would be same. So for the first circle the unit is per second. So for the second circle the unit would also be per second, and for the third circle the unit would also be per second, because they must be having the same unit. So from this thing you get the unit of C straight away, which is the unit of C is S power -1 per second. So you can get rid of the option A and option C because they reveal the unit of C as second, not per second. Now you can find the unit of B as well. So for the middle circle, for this whole term, B over meters, the overall unit of this term should also be per second. And from there you can make B the subject and meter would be multiplied on the other side. you'll be left with ms minus 1 meter per second. So that would be the option B. Okay, let's take a look at the next one. A hollow cylinder which is open at both ends has a radius of this 3.0 plus minus 0.1 centimeter, and length is also given. We need to what is the value means you need to find the principal value along with the uncertainty, absolute uncertainty, not the percentage or fractional. For what? For the surface area of the cylinder. So this is what your cylinder looks like. And the thing is, the surface area of cylinder that we study in O level or IGCSE mathematics is, the formula is 2 pi RL, which is the area of the curved surface, plus 2 pi r square, which is area of the two faces, the top and the bottom, in this case the top and the bottom. But the thing is, they have stated explicitly in the question that the cylinder is open at both ends. So you will not be including the area of the circle, not area of the circle at the top or the circle at the bottom. So 2 pi r square is thrown out the window. So we can find the surface area, principal value of surface area, by using this formula, 2 pi RL. So 2 as it is, pi as it is, the value of r, the measured value is 3, 0.1 is uncertainty. We'll use it for the second part for calculation of uncertainty, but the value of radius is 3, the value of L, the length, is 15. Then you hit it on the calculator and you get the option 282.7. okay, so you get this answer, centimeter square. Now you see, you have only one single option. There's only a single option that reads 282.7 centimeter square for the principal value. And many of the students, they will be tempted to use or pick B as the right option. You should not be doing that, because 282.7 in 2SF, it can also be written as 280. So we cannot be sure if they have rounded off to significant figures or not. So we better be calculating the absolute uncertainty just to make sure that we're going to get the right answer. So now I'm going to find the uncertainty. So what formula do we have? Surface area, I'm going to rewrite it. Surface area equals to 2 pi RL. In the calculation of uncertainty, all the quantities that have no unit or the constant numbers, those are ignored. So 2 pi is ignored, thrown in the trash can. We are left with R and L. And radius and length, they are being multiplied. According to the rule of combining uncertainties, if the quantities are being multiplied or divided, we add the percentage uncertainties. This is what the rule says. So I'm going to find the percentage uncertainty of radius and the percentage uncertainty of length. You can find the fractional, but I'm going to find percentage. So percentage uncertainty of radius would be 0.1 divided by 3.0 times 100, and the percentage uncertainty of length would be 0.1 divided by 15 times 100. Can you hit it on the calculator, both of them? Percent. Now what is the total uncertainty? You combine these two, you add the percentage uncertainties, and the total that we get is this answer plus 3.3. So we get a total of 3.96. 3.96666. So I'm going to write it as 3.97. But they have asked you for the absolute uncertainty. So what you can do is you can find out the absolute uncertainty from the percentage. So all you got to do is find how much 3.9% of your principal value is, or what is 3.97% of 282.7. So mathematically we find it like this: 282.7 times 3.97 divided by 100. And then we hit it on the calculator. 282.7 times 3.97 divided by 100, we get 11.2, and in one significant figure you can write it as 10. So uncertainty is 11, or in 1SF it would be 10. So A would be the right answer for this one, because the second option, the part B, although the principal value is accurate, but the uncertainty is not even close to the actual answer. So here we have the next question, which is not an SI unit. Amperes is the SI unit of current, kilograms is the SI unit of mass, coulombs is not an SI unit. Why? Because it is not in the table of 7 base units. Only the units that we mentioned or that we have written in the table for the base units, only those are your base units. And coulombs is not a base unit. Matter of fact, coulomb is a derived unit, and it is written as amperes times seconds. In base units, we write it as AS. Okay, then we have the next one. What is the best estimate of number of atoms? So I'm going to skip this one for a while, because that demands you to have the concept of number of the moles and for the Avogadro's constant, Avogadro's number. So I'm going to skip this one for a while. We proceed to the next one. So a copper wire has a true diameter of 42.03 millimeters. So we can write it over here. The true value is 42.03 millimeters. Okay, this is your true value. And what the builder measures, he takes 5 readings. His first reading is this one, second this one, third, fourth, and fifth. He has taken 5 readings and come up with these answers. So if we compare his readings with the true value, so the readings are not close to the true value. Readings are not close to true value. That means these readings are not accurate. So accuracy, no, there's no accuracy in that. It's not accurate enough. Let's talk about the precision. You see, the readings are quite close to one another. All these readings that the builder has measured or has taken, the readings with respect to one another are very close. Like the maximum deviation or the range of the readings is 0.02, which is quite small compared to the readings that he has made. Reading is 48 something or 47 something, but the range of the data is 0.02, which is too small. So the readings are quite close to one another. So we can say the precision is there, but the accuracy is not there. So precision check, accuracy cross. So precise but not accurate. D is the right answer for this one. Then we have the next one. A stone sinks in water. What is the possible value for the density of the stone? So first of all, density is measured as mass per unit volume. So it must be having the units of kg per cubic meters, or the other unit that we prefer is gram per cubic centimeters. So C and D are out the window because they are measuring the density in terms of Newton per cubic meters, which would be force per unit volume, but density is mass per unit volume. So a stone sinks in water. What is the possible value for density of a stone? So you see, you're left with only 2 options, and all you can do is pick up the greater one. So this thing is 2000, and the first one would be 800. So just pick up the bigger value. because you're left with only two options, and whatever the bigger value is, obviously that density has to be greater, that is going to be greater than the density of water. And I mean, they cannot give you two values in such a way that for both of them they are greater than the density of water. Otherwise you would be having two correct options. So there would be only one correct option, and which one? Just the bigger one. And by the way, if we write down the density of pure water in SI units, that is 1000, and from there you can also see that 2000 is greater than 1000, so the stone would sink in the water. And if its density were less than that, then the object would float on the surface of the water. Okay, let's move on to the next one. So which is the largest and which is the smallest unit? Okay, so unit is accompanied with a prefix. Okay, there's a prefix with the unit. So the largest prefix that you study in your syllabus, in A-level syllabus, is tera. How much? Million times million, that is 10 raised power 12. And what is the smallest prefix that you study in your syllabus? It is pico, which is 10 raised power negative 12. So straight away you get the option D. The largest unit would be terameters and the smallest unit would be picometers because of these prefixes. Okay, let's move on to the next one. Two measurements for a solid sphere are shown. Mass is given, diameter is given. They are used to determine the density of the sphere. What is the percentage uncertainty in the density? You're not supposed to find the principal value, so don't find the principal value. Don't waste your time on that. You're supposed to find the percentage uncertainty, not even absolute uncertainty. Forget about it. You're just required to find the percentage uncertainty and nothing else. So the formula for density would be mass over volume. Now since the quantities are being divided, so we use the rule, if the quantities are being multiplied or divided, then their percentage uncertainties are added, and we had to find the percentage uncertainties anyway. So what is the percentage uncertainty in mass? So it would be 0.1 divided by 32.5, and you can find the value of it. Just hit it on the calculator. So 0.1 divided by 32.5 times 100, you get 0.31 0.31%. Now what is the density in diameter? You see, for volume, what is the formula for volume of a sphere? The formula for volume of a sphere is 4 over 3 pi r cube. So technically we should be finding the percentage uncertainty in radius, not in diameter. But the thing is, the percentage uncertainty in diameter always equals the percentage uncertainty in radius. These are always equal, not the absolute ones. I mean, if I am to write the absolute uncertainty, so the absolute uncertainty of diameter is twice the absolute uncertainty of radius. So these, or in simple words, if we talk about the absolute uncertainties, then these are not equal, but percentage uncertainties, these are equal. So what you can do is, if you don't believe this thing, convert the diameter into radius, divide this thing by 2, then you have to divide the uncertainty by 2 as well, then find the percentage uncertainty of radius, or find the percentage uncertainty of diameter directly, which I'm going to do over here. 0.04 divided by 1.87 times 100. You'll be getting the same answer either way. 0.04 divided by 1.87 times 100, you get 2.55. 2.55. Okay, so that much percent. So this is the percentage uncertainty in diameter. So this is delta d percent. but technically it is the same as the percentage uncertainty in radius, because the ratio, what you're doing is when you convert the diameter into radius, you're dividing the diameter, principal value of diameter by 2, but at the same time you're dividing the uncertainty by 2 as well. So the ratio would be same, and if the fraction is same, you multiply by 100, you'll be getting the same answer. All we gotta do is, we have found the percentage uncertainty of radius. Now we gotta multiply it by 3, because the rule of exponent applies here. So this thing is basically like this. Forget about the constant numbers. So r cube means r times r times r. So you need to add the percentage uncertainty of radius 3 times, or just simply multiply this thing by 3, because we had r cube. If we were having radius or square of the radius, for example in area, then we would have been multiplying the value of percentage uncertainty of radius by 2. But in this case we have cube, so we multiply by 3. So answer multiply by 3, we get 2.13. You can hit it on the calculator, 2.13, and then this thing multiply by 3, you get 6.4%. Then you add these two percentage uncertainty. This is a percentage uncertainty in radius, in mass, and this is a percentage uncertainty in volume now, because we multiply the percentage uncertainty of radius by 3. Now we have the percentage uncertainty of volume, and then we add these two, because in the formula of density we were having these two things only, mass and volume. So we found the percentage uncertainty of mass, we found the percentage of uncertainty of volume. Now we can safely add these two, and you'll be left with D as the right answer. Okay, moving on to the next one. Must be included in a record of a physical quantity, an integer value for the quantity. Okay, so what about this thing, 0.8 Newton? You can have a force of 0.8 Newton. The integer is not a compulsion, so not the option A. An SI unit. SI unit is not a compulsion, because you can have a mass in grams, 100 grams. You can have time, 2 minutes. So we can express a physical quantity with other units as well. So SI units is not a compulsion. It is advised, but it's not a compulsion. A numeric value for a quantity. Okay, let's talk about this one later. Unit expressed in base units. So the base units of force is like kgms minus 2. But can we not represent force in newtons? Can't we say like 3.5 newtons? So base units, once again, is not a compulsion. What about the numeric value? Numeric value is a compulsion. I mean, if you talk about the force and you say there's a force of newtons, but then the question is how many newtons? The number has to be there. If there's no number, then you cannot define the quantity. So number followed by the unit, both have to be there. Okay, then the next one is what is the ohm expressed in base units? So ohm is the unit of resistance. The formula of resistance is voltage over current, and you don't know the base units of voltage, so you gotta do it separately. So voltage equals to work done per unit charge, W over Q. For work, you can use the formula F into D, but I tell the students to memorize the base units of work, that we have kg, m2, s minus 2. And for charge, you have AS, the same class that you're studying right now, AS, because Q equals to I times T. So this is what we have for voltage, kg, m2, s minus 2 divided by our class AS, multiply by A. Okay, so all of it, this thing, this is the unit for voltage, the base units for voltage till here, times the base unit for current. Okay, for I have written over here in the denominator. Then you can combine these two, just use the laws of indices. So kilogram, no other kilogram, it would be written as it is. Meter square, no other meter square would be written as it is. A minus 2 and S would be minus 3. So you have option A as the right answer. Let's move on to the next one. A desk has a true width of 50.0 centimeters. So this is your true value. The student X records the reading as this one. Y records the reading as this one. Which statement about, what is the statement about the measurement of the student X? Which statement is correct? So if we compare the reading that is taken by the student X with the true reading, it is very close to the true reading compared to the reading taken by the student Y. Okay, in comparison, student X is more accurate because his reading is closer to the true value. What is the true value? This one. True value. So his reading is closer to the true value. So X is more accurate than the student Y. But at the same time, if we talk about the precision, there is more uncertainty in the measurement taken by the student X. So the more the uncertainty, the less the precision. So student X has less precision, but he is more accurate. So we're left with option D. Alright, let's move on to the next one. Here we have this question, define power. We can define power in this way, easy way, rate of doing work or rate of energy transfer. Okay, for 1 mark you can just write this thing, rate of doing work. Then we have the next one, use the definition of power to show that the SI base units of power are kg meter square per cubic seconds. Okay, so power equals to work done over time, and for work done you can find it separately by F into D, or I tell you guys, just memorize the units of work done, which is kilogram meter square per second square divided by seconds. So what do you get from here? You get kilogram meter square S minus 3. Let's move on to the next one. The intensity I of the sound wave moving through the gas is given by the equation. Okay, F is the frequency. The unit of frequency would be S minus 1 per second. A is amplitude. The amplitude is measured. Amplitude is basically a length, a certain kind of length we study in waves. But any kind of length, the unit would be meters. Base unit would be meters. V is the speed. Speed is measured in meter per second. K is the constant for which we need to find the unit. Let's talk about the first step in these kind of question is to make the variable for which, or the quantity for which you need to find the units, make it your subject of the equation. So K equals to what? K equals to I divided by everything else would be shifted on the other side. F square A square divided by V. Okay, so this is what K equals to. Then I is not the current, I is the intensity of sound. So at this stage you have not studied the formula of intensity of sound or intensity of wave, so I'm going to write over here intensity equals to power divided by area. Okay, power per unit area, that is the intensity. So what do we have for power? We studied, we did it already up there, kg m2 s minus 3 divided by, for area, what do we have? Meter square. So from here, meter square cancelled out, and you'll be left with kilogram kg s minus 3 for intensity. Now we can use these base units for intensity all the way over here. So the units for K would be, let's plug in the units of intensity, kg s minus 3 divided by the unit of frequency is per second, the base unit. So per second square would be s minus 2. A is the amplitude, so A square would be meter square, and speed would be ms minus 1. So let's do some cancellation. Kilogram would be there as it is because there's no other kilogram here, and let's see if anything else gets cancelled out. For example, downstairs in the denominator, if you combine this one and this one, what do you get? You get s power minus 3. Then that s power minus 3 would be cancelled out by s power minus 3 from the numerator. And if you combine meters, these meters, what do you get? You get meters, meter raised to the power 3, or cubic meters downstairs or in the denominator. If you shift it upwards, so you'll be left with kg m minus 3. So the final base units of this quantity K would be kg m minus 3. What quantity is that? That is your density, mass per unit volume. Pressure is defined pressure. So pressure is defined as, for 1 mark we can define it as force per unit area. Okay, 1 mark in your pockets. Then you have the second part, use your answer in A, subpart 1, to show that the SI base units for pressure are this. Okay, so pressure we defined it as force per unit area. We can speed up from here. Force would be, in base units, 4 would be kg ms minus 2. How do we know? F equals to ma. Area would be meter square. So if you simplify using the laws of indices, it would be m power minus 1 as power minus 2. Let's move on to the next one. We need to find the base units of K. So I'm going to make K the subject, and we'll do everything else afterwards. So K being the subject. Okay, so we're just going to replace the seats of these two students. Okay, K and M. These two students, they were just causing problem on their places, so we're going to just switch their places. Everything else, all the remaining students, they are sitting on their places. So pi as it is, P2 minus P1, that is the difference of pressure. Then you have R4, then you have rho density times time, and then in the denominator, what do we have? We have 8 as it is. K is replaced by M, L as it is. In the next step, in these kind of questions, in the next step, what you do is you ignore the constant numbers, because constant numbers have no units, so I'm going to get rid of them, pi and 8. Now let's talk about the quantities. What is P1 and P2? P1 and P2 are pressure. So P2 minus P1 would be the difference in pressure, and the difference in pressure would be having the same units as the pressure. Okay, so some of the students, they make this mistake. They believe that if you subtract the two values of pressure, the units would also be subtracted. I mean, think about it. We subtract 3 meters from 5 meters. Do we get the final answer as 2 only, or do we get the unit as well? I mean, we do get the unit as well. So 2 meters, we write the unit as it is. Okay, nothing happens to the unit. Unit is written as it is if you add the quantities or subtract the quantities. So the unit would be written as it is. So what is the unit for pressure? Okay, we did it already. You can just check it out from there. It is there in the first part, kg m minus 1 s minus 2. So I'm going to insert the units. So for change in pressure, kg m minus 1 s minus 2. Okay, that would be the units for not only for pressure but for difference in pressure or for the sum of pressure. Times the unit of R is the capital R is the radius, so it would be meter raised to the power 4, times density, rho is density, so kg m minus 3, times would be in seconds, divided by m, which is the mass in kilograms, and length would be in meters. Okay, let's do some cancellation here. Kilogram cancelled away by kilogram, and all the meters would also be cancelled out. You see, if you combine these meters, think about it, m minus 1 and m minus 3. What do you get? You get m minus 4. Okay, from these two highlighted parts you get m minus 4, and then you multiply with this thing, which is m4. What do you get? You get 1, because if you combine using the laws of indices, you get minus 4 plus 4, you get m raised to the power 0. Anything raised to the power 0 is 1. So for meters, we don't get any meters here. All of them are reduced to a constant number. Okay, so all the meters eliminated, all three of them. Let's talk about the seconds. We have s minus 2 at the beginning, then we have s, and okay, we are left with 1 meter at the bottom as well. Okay, we'll deal that one as well. First, I'm going to write kilogram because one of the kilogram was remaining. M minus 1 was remaining because you have this meters downstairs, so you can write it as m raised power minus 1. Then you are left with two units in terms of second. One is s power minus 2, the other one is s. If you combine these two, this has raised to the power 1. Minus 2 plus 1 would be minus 1. So kilogram per meter per second. Okay, so here we have the last question of this topic, and kind of an easy one. Underline all the SI base units in the following list. So base units we gotta underline. Okay, so ampere is the base unit. Coulomb is not a base unit. Coulomb is represented in terms of ampere and second. Current is a base unit. Sorry. Yeah. Ampere. Current is not a base unit. It is a physical quantity. Kelvin is a base unit for thermodynamic temperature. Newton is not a base unit. Okay, Newton is given in terms of kg ms minus 2. A toy car moves in a straight line. S is the distance, v is the speed, a is the acceleration. Calculate the acceleration of the car. In the first step, we got to find the value of acceleration for 1 mark. No need to find the uncertainty because they have not asked for it. All we got to do is use the formula, plug in the values, find the value of a. So if I make a the subject, it would be v squared divided by 2s, which is basically the third equation of motion we study in chapter kinematics. This is the third equation of motion, provided that the object starts from rest. Okay, so v square, what is the value of v? 2.75. We take square of it divided by 2 times of distance, 2 times of 3.89. Then I'm going to throw calculator at it. 2.75 square so we get 0.97. In 2SF we get 0.97 ms minus 2. Okay, then the next part says determine the percentage uncertainty to two significant figures in A. Okay, percentage uncertainty, we can do that. Kind of an easy one. So you see, you don't need to calculate the percentage uncertainty for these quantities because the percentage uncertainties are already given with the quantity. Instead of absolute uncertainties, they have given you the percentage uncertainty. So all you gotta do is you need to find the percentage uncertainty of A. So what do you have? You have in the formula of A, you have the square of velocity and 2 times of distance. Now first of all, when you're finding the uncertainty, you can rewrite the formula. So A equals to what? V squared divided by 2s, but I'm not going to write the constant numbers because they have no role in these kind of situation, especially when you have a non-linear variable. So you don't need to do anything with the coefficient. So what is the percentage uncertainty of speed, and what is the percentage uncertainty of distance? All you gotta do is add them. But for the percentage uncertainty of speed, you have to multiply by 2 because the exponent of v is 2. Or basically it is written like this: v times v divided by s. Or now you're adding the percentage uncertainty of speed twice, and then add whatever your answer is, add the percentage uncertainty of distance in your answer. So 2 times of 0.8% plus 0.5. Why 2 times of 0.8? Because you have square of speed, and that would be compensated over here according to the fourth rule of combining the uncertainties. If you're not aware of the rules, you can watch my video on it. I've explained all those rules with the help of examples and solve sample questions explaining those rules as well. So what do we get from here? We get 1.6 plus 0.5. What do we get? We get 2.1%. Okay, the last part is use your answers to determine the absolute uncertainty in the value of A. Okay, so what was the principal value? 0.97. The principal value of A was 0.97. What is the percentage uncertainty? 2.1%. All you gotta do is find 2.1% of your principal value. So 0.97 times 2.1 divided by 100. So I'm going to hit it on meter per second square. So your final answer, if they ask you to write the final answer, it would have been written like this: 0.97 plus minus 0.02 meter per second square. The unit is with both of them, not with the first one, not only with the second one, but with both of them. So that was it. In this video, I've solved all the questions that we have from 2023 past papers from the topic of base units and uncertainties of chapter number 1.